Hey everybody, sorry to keep you waiting. We were just making sure everything was set, so hopefully you grabbed some pizza, and I'm gonna do the typical housekeeping here. So if you haven't been here already, we do have restrooms that are just across the hall, co-ed restrooms, and then there are gender-specific restrooms around the bank of elevators there. So feel free to, head on out, but we just ask that, if you're doing that while someone's talking, you be semi-respectful of whoever's speaking at the time. So these stairs are kind of noisy, but do what you got to do. Just want to real quick thank our sponsors before we get things going here. Artifact Uprising is sponsoring the event for really the second consecutive month, so huge props to them and thank you to them for their support. We wouldn't be able to do this sort of event and feed everybody here and provide drinks without the support of some of these Denver area companies who are, looking to keep the community healthy and thriving. So really want to thank them, and as usual, want to thank Turing and Salt for helping us keep this thing running. So yeah. And I did want to give an opportunity. I have a who's hiring board up here. If you didn't get a chance to write that down, maybe take in between our talks, we'll have some time for you to do that. But does anyone have any hiring announcements right now that they want to mention? Anybody hiring? Yeah.
Hey, thanks. My name is Trapana, and I just put my contact info up there. I'm from Core Power Yoga, and we have a lot of React Native and ReactJS work that we could use some help with. So if anybody's interested, hit me up.
Cool, thank you. Anybody else? Nobody else is hiring right now? Okay. Fair enough. Any announcements? I know it's kind of before the holidays, so there's probably not as much going on as usual, but no announcements. Okay. Well, one last thank you. I usually mention this, but I do appreciate you guys coming out tonight, everybody here. I imagine we have some people on the live stream for people who can't make it, but especially with the daylight savings change, it can be difficult to muster up the energy to come and attend a meetup, and we do appreciate you spending your time with us. There are a lot of meetups in Denver that are great, and yeah, thanks for being out here. So with that, I will get into our first talk. So I've had the pleasure of working with Doug in the past. He's a really smart guy and great developer. So he's given many talks here before, and I'm looking forward to this one. So if you could, please give him a round of applause.
I think I'm going to try. Cool. Yeah, I'm glad to be here speaking again. I always enjoy coming here. The feedback is always great, and it's always a great turnout. But if I knew there was going to be this many people, I would have put together a better talk. So, yeah, this is vanilla JavaScript for the average developer. And I'm Doug Whitney. I work at a company called Wireless Registry. We're out of Washington, D.C., but most of our engineering team is here in Denver. And we actually are hiring for a mid or senior level data scientist right now, so if you know anybody, check us out. I also identify as an average developer. I think you can kind of come up with your own definition, but don't take it too seriously. I think it has something to do with recognizing that there's always somebody who knows a little more or is willing to work harder than you are, and it's kind of your choice if you want to push yourself to try to keep up with that, or is there a point where good enough is kind of good enough? In terms of front-end context, maybe you have a computer science background, but you're new to the front end, or on the flip side, maybe you have some experience building things, but you don't have the kind of formal training. But again, maybe you just like to do things outside of work, besides write more code. So my objective tonight is to kind of answer these questions. What really is vanilla JavaScript, and why should you care at all? And also, I'm going to be kind of generalizing things. Let me know if there's questions along the way, or if I kind of misstate something or get something wrong. I am an average developer. So this is not about how to write your own framework. It's not about trying to approach modern web development with no framework. This article that I linked to was from 2014, and I think it's kind of funny in hindsight, right, to declare that we're not going to use front-end frameworks anymore. And again, for context, I work with React every day and really kind of appreciate what it gives us as developers in terms of the developer experience and just making it enjoyable to work in JavaScript as well. So I almost talked myself out of this topic several times, not really knowing if it was going to be useful. I think the arguments, right, about using vanilla JavaScript or approaching it from that direction are sometimes these. But the more I thought about it, I think there really is value in kind of exploring things from this perspective, right? Because everything interesting on the front end is really made up of much more simple building blocks, the kind of low-level APIs that are available in the browser environment and from JavaScript, a core language. And I also think that knowing the core language makes you better in your chosen framework or whatever stack you are working with right now. I think it's also this idea of surface area, just how much ground can you really cover, and if you're using React or any other library or framework as kind of your entry point into JavaScript, there's a good chance that you're missing some of the interesting parts because of all of the hype and churn around React and Redux and everything that goes into that ecosystem. And there's also a lot of incentive for people to convince you that you should be learning what they're pitching, whether it's just for their resume or they have advertising to sell or whatever it may be, I really like this visualization. I forgot to add the link here. This is from, can't remember the domain at the moment, but it just shows the explosion of web technologies and APIs over time. And again, surface area. How much of this can you really absorb? And I think there's a point where you have to kind of draw a line in the sand and say, what can I make use of now? What can I keep kind of adjacent because it looks interesting and it might be helpful in the future? But you can't cover everything in reality. I'm not sure if I came from here yet. Let's see. Within slides, I'm not sure how to. It doesn't actually zoom. But yeah, I'll I'll see if I can remember the link, or I'll add it to the slides afterwards. You guys can check that out. I like this quote, you know, the web is the most hostile software engineering environment imaginable. And I don't know if you recognize the name, but this is the guy who wrote JavaScript, the good parts, and the original JS lint. And he had an interesting take on JavaScript at a, you know, a very early point in time. And I think this quote still holds up. So. Anybody remember or currently work in Backbone? You don't have to raise your hand if you like currently work in Backbone. I mean, so it came out in 2010, and the latest stable release was in 2016. I also worked on a large Backbone app during this time, so you know I feel your pain. There are over 24 million Google results related to all things Backbone. So, you know, imagine blog posts and Stack Overflow questions and videos and books and conferences and tutorials. And nobody is building new things in Backbone right now, right? I mean, kind of just a reminder that the tech has a very short half-life. And there can be benefits to kind of deferring some decisions when you don't know what is going to stick, right? And just a reminder that there's going to be a successor to React as well. You know, if we're all doing this 5 years from now, things are going to look different. Maybe it'll all be, you know, WebAssembly. But at the same time, you're going to need to understand the browser as a dev target and how to, you know, work with its APIs and how to manipulate it effectively. So this is, you know, what I am talking about when I talk about vanilla JavaScript. Everything that you get for free in the browser environment without the cost of loading any external libraries. And most of these things are, you know, guaranteed to be available depending on what you're trying to do. So, you know, from the core language, we get things like math and array and function and just, again, all of the primitives and the very basic building blocks that are going to be available whether you're in the browser or Node.js or, you know, somewhere else that implements native JavaScript. The browser object model differs a little bit between browsers because it's not actually a spec, but right, it's how the browser models and exposes its own capabilities to JavaScript. And you know, as you can see here, it roughly also encapsulates the DOM, right? That's part of the browser object model and familiar, you know, APIs there. So, you know, from this point, I'm going to jump around a little bit. Hopefully, I'll be able to tie things together at the end here. Some of these are things that I wish I knew earlier about JavaScript in the browser. Some of it, I think, is kind of assumed knowledge once you have been working in the front end after a certain point. But, you know, if you are not encountering these things, they're easy to overlook or forget. So, you know, a couple of questions to start. Is JavaScript compiled or interpreted? This is one of those things that I never really understood. And when I went to kind of find the answers, it was not really clear. I mean, the answer, you could argue, is yes, it is compiled and interpreted. But I think the more accurate answer is that it depends. The language itself is agnostic, right? It depends on the host environment and its implementation. But in practice, you usually end up with some combination. You know, most of our front-end projects have a transpiling step where we're converting things from, you know, TypeScript or ES6, possibly CoffeeScript, down to ES5. And of course, this all happens before it gets to the browser. then your transpiled code is handed off to the browser's ECMAScript engine. And in the past, it was fair to say that at that point, the engine's interpreter takes over. But I think with some of the latest developments to V8 and the Firefox engine and some of the just-in-time compiling work that they're doing, the distinction between interpreted and compiled is less meaningful. And just as kind of a side note, the discussion on Stack Exchange was labeled as not constructive because it just didn't really fit their guidelines. But still an interesting question, I think. So kind of the same thing with object-oriented or functional. The language itself supports both, so you're not, if you want to take either approach, you're not having to shoehorn it to fit. It really depends, though, on how you and your team choose to use the language. And these things aren't mutually exclusive. If you try to elevate one of these as like the one true way, I think you end up in a strange spot where the kind of dogmatic approach starts to overshadow the fact that the code is really a means to an end, and you're trying to build a product and not write, the perfect program. And again, I think in practice, you usually end up with a combination of both object-oriented and functional code. I've come to like this idea for thinking about how to organize a large application. It comes from a talk. Again, forget the guy's name, but it was originally about testing Ruby applications, and this idea that by kind of organizing your application around a functional core and an imperative shell, you kind of get some benefits for free, right? And then more recently, the idea has been adapted for, to talk about a reactive shell, which fits well with what we're talking about in the world of React. So the shell deals with things like managing state and handling user input and network I/O, and the core is primarily pure functions without side effects, things that can be tested and reused. And again, more than anything, this is kind of a way to think about organizing an application. And then the boundary, right, the inner functional core versus the outer imperative shell, that boundary, I think, differs, again, depending on what your team preferences, your level of experience, and how you want to structure things. This is one of those things that, again, you hear all the time. Doesn't always get explained well. Everything's an object in JavaScript. Well, what does that mean, right? In one sense, it means this. We can, try to query JavaScript and say, what is the value of the type of this value? And in all of these cases, we're going to get back object, right? And it just kind of shows that, one, that's not a very useful check. But two, like on lines 9 and 10, not sure that's necessarily what you would expect, right? When you ask for a number and you get back an object. The one exception here is just showing that in most cases when you call a new primitive, a constructor of a primitive, you do get back object. The exception is function. But these are not especially useful, these last three cases. Right, I mean, this, again, is just showing everything's an object. We can create an object and add things to it. In this case, we're just adding a simple method. But then you can do things that you really shouldn't do, right? Like, let's create a function and assign it to a variable, and then let's start adding properties to it. So we can have a function with a description and a function whose property is also a function. Like, you can, but do you really want to do that? I don't think there's a lot of good cases unless you're doing something really interesting with the language itself. But just illustrating again that everything is an object. So building on the idea that some of these are just not very useful because when you want a number, you don't necessarily want an object. You just want a number. So what is more common than creating a new string is just having a variable and assigning a string value to it. So it's a primitive, right? It does not have any properties or methods, but on line 12, right, we can still query the length, and somehow that works, even though it's a primitive without any methods or properties. And the interesting part of that is that JavaScript knows when you ask for length to wrap that primitive in the corresponding object. So essentially, behind the scenes, it is doing new string for you so that you can query the length property, and then it unwraps that value so that the next time you use s, it's still a primitive. And hopefully this illustrates that a little better as well. What you usually want is the second case, but if you are expecting to get a number back out of the first case, you're going to be disappointed. This is another one of those things that took me a lot longer to understand than I care to admit. But people talk about pure functions and side effects kind of interchangeably, and again, that's kind of one of those pieces of assumed knowledge, but if you don't understand, it's hard to grasp, right? But looking at this function, it is not a good example, right? Because a pure function relies only on its inputs and outputs, and as a result, your program can substitute the function call with its actual value, and you're really guaranteed to get the same result. But in this case, on line 3, right, we're operating on something that is not one of the inputs to this function. So there's not really a way to know if it is mutating the value of x, or just like what the state of the world is before and after this function runs. So pure functions, again, only operate on their inputs. They always return a value. And you get some benefits out of that, like easier testability, the ability to compose things, and work with kind of arbitrary data. Another core part of JavaScript is that everything is asynchronous, just about. And I think it becomes clear when you read this quote. This really describes any kind of modern web application. We know a bunch of things are going to happen and that we're going to have to deal with them, but we don't know when or in what order. So, that's the nature of the asynchronous operation of JavaScript. And it emerges in a lot of places. Set timeouts, any place we're doing event handling, we're working with kind of more explicit asynchronous functions. And of course, just about everything in Node.js is asynchronous as well. We won't get into this, but the event system is an important part of it too. Understanding the event loop and callback queue and how that adds capabilities outside of core JavaScript and kind of gives you like a pseudo multi-threaded environment is a really important part of JavaScript and the browser environment as well. And I believe React uses event bubbling or delegation and attaches all of your handlers at the document level. Does anyone know if that's correct? Right, and just another kind of interesting piece that, if you don't have some of that experience from working at a lower level, it's just really easy to overlook. But there's some performance benefits from doing that, and for whatever reason, React has chosen to kind of implement that same pattern. And just the idea that a deeply nested component, if you click on that, that event is going to bubble all the way up to the top of the tree unless you do something to stop it in between. In working with ES6, these are just, again, some of my favorite parts. It's all sugar over existing syntax, I think, for the most part, but the benefits that you get in code, I think, are worth learning these pieces, just in terms of readability and expressing your intent, and for other people on your team to be able to pick up what you were doing and understand it easily. On that same note, modules, I think it's easy to overlook the real benefit that we get from that in terms of being able to break down and organize a program. This is a pattern that that we use pretty frequently to take on the top a bunch of default exports, just a bunch of individual components, and then in the same file bundle those all together so that on the consumer side they can be destructured using one import instead of having to repeatedly import these things from a repetitive path. This, I think, is also just an interesting piece, why the kind of fat arrow for anonymous functions with ES6. And this comes primarily from CoffeeScript and just some of the benefits that people saw in using that approach, right? Where versus a regular function where the this binding is determined, on a set of rules about how you created the function. This always guarantees that your this binding is lexical scope, right? Whatever this was before you got into the fat arrow function is what it's going to be inside of it. So just easier to work with, easier to reason about, and just a cleaner implementation as well with the kind of implicit return, because you're often using these in a map or a filter where all you're doing is just checking one property and returning things based on that. JavaScript is a mess, right? It is definitely, again, large surface area, in part because it remains backwards compatible, it's unversioned, and it has a ever-expanding feature set. I think, for the most part, features aren't generally removed from JavaScript, which, again, you have a lot of kind of baggage to pull forward and ensure that things continue to work. But you get some really cool things with that. These are just some of the interesting browser APIs. One of my favorites at the moment is Webgl. You don't have to work directly with Webgl, which is a really low-level API. There's some great packages built on top of it. But what it allows you to do is do 3D graphic rendering on the canvas element using the GPU. So you can work with data sets that would kill your computer otherwise, but because you're handing this work off to the GPU to generate the visualizations, it is far more capable of handling large data sets and gives you the possibility to do some really interesting things. WebSockets and web workers are also really kind of compelling APIs. You can do some cool things with those as well. So, I don't think modern web application would be close to what it is without the development of the dev tools themselves. Firefox was really one of the kind of early drivers of this, but Chrome, the dev tools are just incredibly deep and give you amazing insight into an application if you really want to find out what's going on. You could do a whole series of talks just on the dev tools themselves, and that kind of feeds into your own tooling. I think it's important to keep in mind that it is all software. You should feel free to change it or update it if things are slow or convoluted, or the person who wrote your tooling left and nobody knows how it works. Just experiment and iterate and make it better. The important part of that, I think, is that your tooling, your build process in particular, should work for you. It's optimized on one side for the developer experience and on the other side for the browser and by extension the end user. But if your build process is not allowing you to work the way you want, there's no reason that it should be that way, unless you just don't have the timer freedom to change it. So to kind of wrap things up, some of these concepts are things that I try to use on a regular basis. This is just a quick case study of how we use React at Wireless Registry. Not by design, more just by evolution than anything else. And we have deferred some decisions because we weren't sure what direction to go, which is why we don't use Redux. But I don't feel like that has limited us in any way. Things that have helped us are having, again, a small surface area by using a small set of top-level dependencies, and they in turn don't have a lot of dependencies, which keeps debugging and stack traces relatively shallow. And then additionally, instead of having one kind of gigantic app that shares a lot of code, we have a monorepo architecture, and then on the front end, we use Yarn, and we have a very horizontal structure. So we have lots of little projects that kind of live at the same level and share code and import code from each other as needed. And I think an important aspect is that we don't worry about performance before it really becomes a problem. In the year that I've been there, working on a couple of different applications, there have maybe been 3 or 4 cases where we really needed to do a deep dive and kind of make hand-rolled performance improvements beyond what React gave us out of the box. So yeah, I hope this has been interesting. That's all I have.
Questions for Doug?
Yeah. Yeah, we manage it manually. We use local component state where necessary, and we pass things down through the component tree. Again, one thing that helps us is that kind of horizontal structure. So we have a component library, right, that's completely independent of any of the projects, and that kind of boundary helps as well.
Any other questions? No? All right, well, please give one last round of applause to Doug. So we'll take a quick 5-minute break. There is some more pizza and salad down here, so feel free to grab some, and we'll get kicked off with our next talk. Josh Miller is going to be talking about some functional programming in React. So we'll see you in 5.
And that guarantee is that what comes out of that map function, or at the end of this entire execution, it'll be an array. So that's kind of like step one. Like map gives us this like intuition that whatever we map over, we're going to get it wrapped back up inside of that context, array being the context. So think about, just like I said with maybe is a context, array is a context. So array is a context of multiple values, and a maybe is a context of maybe a value or not a value. So it's the same thing, and you can use the method the same way that you do the array.map. And then this is just kind of a cool example of using compose. So before we had to map over each of these functions, which could be a costly map if we have a huge array, right? We have to map over this function and then map over the next function. But we could compose the two functions and map over them one time. And we know that because our inputs and outputs are going to be the same, we're just going from string to string and string to string, we can just chain them all along. So it's kind of nice if you're looking for, I don't honestly know if it's a performance boost. I've never done like a performance test on it, but in theory, I think should be faster. Yeah. And so this is the overlaying concept, the higher order concept of it. So behind .map and that method and that what we just did earlier with .map, it's called a functor. And then these names are going to be weird. They come from mathematicians from like the 1920s, 1910s, so they're goofy for sure. But yeah, the mathematical term for this is functor. And we kind of get a few guarantees. Like I said, it keeps the same shape. So like with an array, we're always going to get back an array. And then we also get this nice ability to lift a function into the context. So we're not having to like pull the value out all the time. We're just saying like, here's a function, run it on the values inside of it. And that's kind of what functor does for us. So here's kind of like the mathy part of this. We get some rules with this, and array.map follows these rules exactly. So the first rule is called identity, and identity basically says that given a function that just takes an input and returns that same input, that's all it does, we can map over that function, and it's the same thing as just running that value through the identity function. Pretty simple. That one's pretty easy. And then the next one is what I just explained earlier, where we can map over a function and then map over a function, and it's the same equivalent as mapping a composition of those two functions. And then this is the type signature. So this is where things get a little Haskell-y. Haskell is I don't know. It's a programming language from like the 80s. It's named after the guy who kind of invented like currying and a lot of these concepts. But I always think it's useful because I find that their type signatures are actually really easy to read compared to something like a TypeScript, just because they're very simple. And so our map function here, we have this parentheses, A to B is our function, right? So think of it as string to string in our two upper function example, right? And then we have an f of A, and that f stands for functor. And so we can think about that as like our array of string, where f is the array. It's the functor that surrounds the value inside. And then A is our value inside. And then we have this function that's going and taking all the A's, turning them into B's. And at the end, we're going to get back our f of B, because it's going to be wrapped back up inside of the array. This is kind of like generics in Java, or TypeScript even has generics, where our A's and our B's here are generic types. Basically, the map function does not care what you put inside of it. You could put a function inside of it. You could put an object. Anything you want can be wrapped up inside of this functor type, which is really nice. So yeah, like math, whoa. And I hated math in school, and this is like more fun math. So here's a simple functor implementation. So we're going to create a type. So we have our array type, our maybe type. Let's create a type that we're just going to call box. And really this type is going to have no significant value. It's kind of a worthless type. The only time you would ever want to use this type is maybe for like testing purposes. But just to show how we can construct our own map function, where we're taking this box and we can say box of, which takes a value and lifts it into our context of box. And then we have our map function. And basically what we're doing is we're returning, the function gets passed in, we run the function on the value and return it all boxed back up. And then here's like an implementation. This is kind of a toy implementation, but this would be an example of our maybe value that we used earlier, or our maybe context. So same thing as box, we just have like a maybe that stores a value and a maybe of to make it easier instead of having to write new maybe all the time. And then we have kind of a nice little isEmpty function that can check and see if our value is null or undefined. And then this is where things get really cool, because in our map function, we can say, all right, if this is empty, we're just going to return a nothing in this instance, which I didn't define nothing in this, so it's this is why it's a toy implementation, but we're going to say, we're just return a maybe of null. Or if it isn't empty, we're going to return a maybe of and run the function on our value. Now that's where it's really interesting, because if you look at that example, and if we go back to, actually I think I have it up here. Yeah. So we kind of get a guarantee now. Whenever we have this prop name user, if that name property doesn't exist, then that map function will never ever get run. And that's super handy, right? Because now we can't get that undefined is not a function error that we had before, or yeah, just undefined. We get a guarantee. And then the other awesome thing is we force ourselves to handle that case. So because we're all wrapped up inside of the maybe still, so we have to find a way to call it out of the maybe and handle if there isn't anything there. So we can't forget that if null check, which is great. So here's like an example of how to do it in kind of React. It's not very Reacty, but this is something that we do a ton in our code base, and we use React and Redux. And what we do is, like, anytime that we have a value coming in from Redux or somewhere else, API or something, we will wrap it up inside of this maybe value, like, to start with. And we can say, like, maybe from this nullable thing. And now anywhere that we use it in our React code, we're forcing all the developers on the team to make sure that they handle if that value is there or not. And we kind of get that guarantee because the developer can't, you have to call get or else in this situation to get it out of the context. So I'll explain some of this. So we have our prop function, like we have our object of name and username, and then we have a kind of a profile component. And here we're saying, all right, we want to grab the name, and if it's there, we're going to take that name and put it into and concat it with hello, your name. And if it's not there, we have this little get or else that says no name found. And then same thing down here with age. If there's no age found, which in this case there isn't an age, so we should see this no age found display. And then lastly, a username. And look at that, it runs. It's not very pretty, but it demonstrates it. But so yeah, so you can see the name there, and then we've got age. We have no age found, and then we have our username. Anybody like soccer? No? All right. It's just me. But yeah, before I jump into the next part. But yeah, it's a really great way to kind of ensure safety across your team, because you really kind of force everyone to handle all the cases. So next, monad. So we've covered functor, and that one I think is probably one of the easiest ones to understand because of JavaScript's array.map, right? So monad's going to get a little weirder, but it gives us some awesome things. So it allows us to combine multiple contexts. So in that instance, it allows us to combine like arrays with arrays or maybes with maybes. And it also allows us to control the flow of our program. So it allows us to create synchronous code, kind of like you would with like a promise dot then chain. So it can kind of do something similar to that. And before we jump into like monad in general, I just wanted to show off another one of the data types that we can use. So we have array, we have maybe, now we have either. And either is going to be almost the same thing as a maybe, but we add a new, instead of just a value or a nothing value, we now have a left value and a right value. And the right value is going to be our success case, and the left value is going to be an error case. And what's awesome about that left value is we can store something inside of it. Whereas with the nothing value, we actually can't store anything in it. So it just, like, we don't know what happened, but for whatever reason, that value's not there. With this, we can actually know what happened and why that value isn't there. And so this is kind of some React code using that. And can everyone see that? I don't know if I can, yeah, cuts it off. But we have a kind of a React component, and we're going to validate a field. And we have kind of this form component, and then we have kind of some helper functions that say, so the two things that we want to validate for are making sure that our field isn't empty, and we say, like, if that value has a length of greater than 0, then awesome, we're going to return an either of our value, which is going to be a right or a success. And then if not, we're going to return an either.left, and we're going to say field name needs to be filled out. And then invalid, not invalid chars is going to also take a field name and a value, and then we're going to say, yeah, if that value contains any of those characters, then we're going to return a left and say that field has some invalid characters, or we're going to return our value in the either context. Yeah, and then we kind of have this validate field function that will run our value and our field name through it. And you can see this dot validate field name. We're going to take the target and see if it works. So another really good looking React component to test. I really spent time on styling. But that is weird. And you can see, like, whoa, it's got like either dot right in there. That's not what we wanted. So if I go back to the code, and if we look at the validate field method on our React component, you can see there that we're validating first the non-empty field, and then we're mapping that to validate the not invalid characters. But the problem is that map guarantees that we're going to wrap it back up. And then we have two functions that are going to return contexts all by themselves, right? So both functions will return an either. And if we map one over the other, we end up with an either of an either. And that's like not what we want. That's weird. Why would we want that? Luckily, there's a way. There's a way to fix that. And that is where monad comes in. And I'm going to start with kind of the type signature. And you'll notice that it's very similar to Functor, right? So in Functor, we had f of a and an a to a b function, and we returned back an f of b. Here we replace the f with m for monad, and instead of our function just being a to b, our function is now a to m of b, which means that our input to that function is a regular value, but the return value is going to be wrapped up inside of a context. So in our case of validating these fields, it's going to return an either value. So what's nice is the chain function guarantees that we're going to unwrap one of those values. So we only get one back. And here is kind of the building blocks of how we would build that. So we'll go back to our maybe function just because I think it's very easy to follow. And we'll say, all right, we're going to add this new join method to it. And we're going to say, if it's empty, we're going to return this null value again. Otherwise, we're just going to return the value because we're just lifting it out. We're not wrapping it back up. And if you remember the map function would wrap it back up automatically. Here we don't want that. And so you can see we have this maybe of, hello world, and if we join them, we just get maybe hello world instead of maybe. And then this is where chain gets implemented. So chain, we take a function, and we map the function over the joined types. So we first join them, and then map our function. Does that make sense? That one's kind of a hard one to follow. But yeah, so join is going to unwrap one value. So we unwrap one of the values, and then we can just map because we're inside of the context, and we know that it's going to have a functor instance. So we can map the function over the one value. And that's what chain does. So now we can rewrite this same code, except for I replaced the map with chain now. And that basically should allow us to only get back one either out of that chain of both validations. So now if we run this, hey, it's normal, and oh, it needs to be filled out. And then, oh, that's an invalid character. It's not a great React component, I admit. But the concept. So where do we go from here? Like, let's get even crazier, right? We've now done functor, we've done monad. Now we're gonna do applicative. And applicative kind of helps us out when we have two values wrapped up and we want to do something with both of those values, like run a function over both those values. And yeah, so here's an example of that. So let's say we have a first name, last name, maybe of Josh, maybe of Meller, and then we want to concat these, but we can't run this name function over maybes. Like, it doesn't know how to work with maybes. It only works with strings. And that's annoying, right? Like, how can we fix that? So here comes applicative. So applicative, you'll notice, is also just like that functor type signature. We have our f of a, once again. But the interesting thing here is the function type again. So instead of just a to b, we now have f of a to b. So what that means is we're literally lifting the function into our context. So in the instance of array, we would be taking a function into an array. Or in our case of maybe, we would be taking the function into the context of maybe. Yeah, and then our type knows how to run the values and get back our f of b. So here's how we'd actually implement that for our box type, our really simple type. So b is our function, and b, remember, is wrapped up, so it's a box. So we can run b.value over our value and wrap it back up. And so that kind of gives us a way to, and here you can see the type signature again. So in this case, b is already wrapped up inside of a box type or box context. So same thing. Instead of having to rewrite our name function to accept maybe values and know how to work with maybe values, we don't have to do that. We can let our functions be simple on the types they use and not really care about the context at all. We don't have to care about the context. We just let maybe take care of that for us. So we can say maybe of and lift our name function into it. And this is where it kind of gets important with currying and composition and stuff. You'll notice that the name function is curried, right? So first name, return the function, last name, return the value. So in this case, what is going to happen is we'll apply the first name, which is our maybe. The maybe value, when it gets run with that applicative, will unwrap it and then run it on our function name. And then it's sitting there waiting for the next value to come, which then we have dot app or apply last name, and then it actually gets run. So yeah. So this is where it gets kind of like really powerful. And I don't know if this is truly async, so that's why I put async-ish. So maybe someone could correct me, I don't know. But let's say, so this code is a little hand-wavy because it's a little like not fully implemented, but we have a task, right? And a task is essentially a promise, but it has the chain methods and the map methods. Instead of .then, you just do .map, and you can do .chain. So here we have two task functions like getUser, which is going to query an API, and then getUserFriends, which is also going to query an API. And we pass in the user ID. Now, both those functions are going to get run, and then we want to apply them to our React component, which then is going to take in the value of the user and the value of our friends. What stinks is, like, normally you would have to, well, yeah, you can't, yeah, trying to think of how to explain that. But what's nice about Applicative is you can run both those functions simultaneously, and the end component doesn't care when they come back. But it will only run that component and render that component when both values have come back. So it should, in theory, and I don't know a ton about like JavaScript and you know how it runs everything, I guess, but with like Applicative getUser, we can fire off getUser and getUserFriends. When getUserFriends comes back, it's ready to apply it to the second argument that's curried here. And then when user ID comes back, it's ready to apply it, and then we can actually get the value. And it won't actually get the value until it has both parameters to its function. So it's really simple in like how you think about it, right? Because it's just a function waiting for the parameter to come in, and the task type or context knows when to apply those different things. And so we can say get or else, and we can say loading. And that's pretty much it. I just kind of have some like really useful links on like different ways to use this stuff in JavaScript. Tom Harding wrote a huge post on like all these data types and how to use them in JavaScript. And then there's a spec out there called Fantasyland, which actually defines how other libraries can implement like .chain. So then you could say like my type implements monad according to the Fantasyland spec. And it's a spec for like JavaScript libraries to follow, so that way you can interop these different types together. And then if you're like really nerdy, you want to get way into it, Type Classopedia is like Haskell's definition of these types, and it goes into like really heavy stuff on like the math behind it, the rules, all that kind of stuff. So yeah, I'd recommend checking it out. It's a lot of fun stuff in there. It's a lot of stuff, but if you start off really simple, like just using something like maybe to wrap values that might be null, you'll see like a huge performance improvement in your code and just way less errors and way less like cognitive overhead for developers. So yeah, that's it.
Cool. Oh, that's loud. Any questions for Josh? I have one. Oh, Doug has one too, but real quick, Josh. Yeah. I've had some issues. We've got a lot of functional buffs at Salt, people I work with who are big into functional programming, Haskell, all that. And I found that some of these concepts are, and still are, difficult for me to grasp. It's just kind of been like a matter of sort of hitting my head against a wall numerous times until it kind of sinks in. Mm-hmm. Have you found that, you know, working in a different framework, like messing around with Elm or Reason is the other one I'm remembering, have you messed around with those at all, and have they kind of helped solidify understanding for you?
Yes. I haven't done as much with like Reason. I've messed around with Elm. I've done a lot of Haskell. And Haskell like has these concepts from like the ground up. But it took me like 2 years to really like understand like what is happening from like a theoretical level. But like in terms of like actually coding it, I've found like for our team, like we have a lot of new people like hopping into this code base who have never done any functional programming. And so we've kind of had like, we have a like small surface in some areas and a large surface of like functional programming. And one of the nice things that we do have is we have flow types. So if you're using like TypeScript and flow types, this makes it a lot easier in JavaScript because it can be really hard to realize that you're in a type. Like, okay, this thing is returning, is it a string or is it this maybe type of string? I don't know. And that's where like TypeScript and flow can really be useful. But yeah, I found that mostly getting someone just into a code base and starting off with like maybe, and just like teaching them like maybe is the same thing as like array.map. And then just like kind of building on that intuition as you go and then getting like hands-on with it. And this Tom Harding has amazing tutorial on all these things. There's also a good tutorial from Brian Lonsdorf on egghead.io called, I think it's called Professor Frisbee's course or something. It's a free one. It's really, really good. So yeah.
Doug? Oh, okay. Any other questions for Josh? No? All right, well, give him another round of applause. And with that, we'll wrap things up here, but have a great rest of your night, get home safely, and we are, just a heads up, we are going to have our next meetup the week prior to Christmas, so we usually try to stick to the third Tuesday of every month, but the holidays kind of have us, readjusting here, so keep that in mind, and we'll see you next month.